Welcome to this week's Science Snippets with Dr. Fuller. Today, we will unlock mathematical secrets of nature with the Fibonacci sequence. After spending so many days cooped up, I thought it would be fun to do an exercise that gets us outside. Today, we are going to talk about the Fibonacci sequence and then go see it in action with a nature walk afterwards. This story starts back around the year 1190, back in the day of Roman numerals. Leonardo Fibonacci was reading some ancient Indian texts and learned that Indian scholars had been using a different method of writing numbers for at least 100 years before he learned about them. Fibonacci was instrumental in sharing this new number system and pushed very hard for its use, particularly in mathematics across the old world. Fibonacci was quite the philosopher, and he posed this question to himself. A certain man put a pair of rabbits in a place surrounded on all sides by a wall. How many pairs of rabbits can be produced from that pair in a year if it is supposed that every month each pair makes a new pair, which from the second month on becomes productive? How many pairs of rabbits do you have in 1 year? So let's look at this. We start with 2 baby rabbits. That's 1 pair. They take 1 month to become adults, still 1 pair. In month 3, the original adults have a set of twins. Congratulations! Now we have 2 pair of rabbits, 1 adult pair and their twin babies. In month 4, the original adults have another set of twins. The first set of twins are now grown up. Now we have 2 adult pairs and 1 baby pair. 3 pairs of rabbits. Is your head spinning yet? Using this pattern, how many pairs of rabbits are there by the end of the 5th month? Press pause here to try and figure it out. Drawing the rabbits may help. In month 5, there are 5 pairs of rabbits. Is that what you came up with? By the 5th month, the baby twins have grown into adults. The original rabbits have another set of twins. The first set of twins has a set of twins. Now we have 3 adult pairs and 2 baby pairs. That's 5 pairs of rabbits. Was that confusing enough for you? Well, Fibonacci developed an equation that would help us solve such questions using numerical patterns. We won't worry with the equation today, but we will look at the pattern that the equation generates. In the Fibonacci sequence, we can start with a number line that has the numbers 0 and 1. Now, if we add the first 2 numbers, 0 plus 1, we get 1. Our number line consists of 0, 1, and 1. If we add the next 2 numbers together, 1 plus 1, we get 2. Now our sequence is 0, 1, 1, and 2. Let's add these last 2 numbers together, 1 plus 2. What do we get? 3. Now our number line is 0, 1, 1, 2, and 3. We can add the last 2 numbers together, 2 plus 3, that's 5. Take a minute and do 4 more rounds to get the next 4 numbers in the sequence. Pause the video here and do your own calculations. Did you get 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34? Let's go back to Fibonacci and his question about the rabbits. Fibonacci wanted to know how many pairs of rabbits you would have in 12 months if you started with 1 pair in a crate. So we'll write out our 12 months here, and then we'll apply the Fibonacci sequence to each month in order, starting with our first pair of rabbits in the first month. Look, we could have solved this question easily just by using the Fibonacci sequence. Now, here's my favorite thing about the Fibonacci sequence. We can actually see this sequence in nature pretty frequently. The number of petals on a flower, for instance, is usually a Fibonacci number. See? 5 petals. We can also see the Fibonacci sequence in natural shapes, like snail shells and pine cones. Look more closely at the pine cone. If you count the number of right or left-hand spirals on this pine cone, you get 8. Hey, that's a Fibonacci number. It's time to take a little walk outside. Look for flowers, leafy plants, or pine cones. Count the petals and leaves. Do they follow Fibonacci's numbers? Where else do you see the Fibonacci spiral or count Fibonacci numbers in nature? Have a great walk today, but remember to social distance. I hope you enjoyed today's lesson. Catch us next time on Science Snippets.